Okay, this will be a short video about resistance, which is really important for us in circuits because resistors are an integral part of every circuit. So first of all, we have to ask, what is resistance? Okay, so it's kind of like, think of it like continuing the conversation about what is a conductor and what is an insulator. Okay, conductors allowing electricity to flow and insulating blocking it. And that's normally what we teach you in middle school, but it's not really that black and white. In fact, it's more of a spectrum of things that can kind of conduct and things that can really conduct well, and things that block a little bit of electricity and things that completely block electricity. So again, it's not just black and white, whether something is a conductor or an insulator, but everything falls on a scale of how well it may conduct or insulate. And so resistance is basically measuring, giving that a number. And so it's basically how much a material or an object will resist or block electrical current flowing through it. It could block it a lot, or it could block it just a little bit. And so you can use that to kind of adjust how much current actually flows through a circuit. So if you want to calculate that resistance, or basically how hard it is for electricity to flow through something, I always like to think of it like water pipes. If you have these two pipes, a short pipe and a long pipe, which one is it going to be harder to flow through? And so the obvious answer is the longer one, right? This one has a shorter distance, so it'd be really easy to flow through. This one takes a lot longer because it's a longer pipe. Okay, similarly, if you have different size diameters or openings, and which one is the hardest to flow through? Well, it's obviously going to be the smaller ones, because this is going to have a really easy time flowing through it because you have a wide space, and this is a lot more narrow, so it's going to be more difficult. So when you're calculating resistance with your equation, resistance, which is the letter R, and we measure resistance in ohms, or the symbol omega, is equal to rho times L divided by A. Rho is resistivity, and the units are ohm meters, and resistivity depends on the material. So example, rubber is going to have a really high resistivity because it is going to really block electricity, whereas metals will have extremely low resistivities. Okay, L is the length of your either wire or pipe. I mean, again, think of the pipe analogy. The longer the pipe, the higher the resistance. So L is length in meters. And then A is the cross-sectional area. So if you cut your object in half, what is the area of that side, that cross-section, in meters squared? So again, small areas are going to give you very high resistances, and big areas are going to give you really low resistances. Because you have a big area, you have a lot more room to actually pass through. So for example, if you have a piece of silicon and it has a resistance of 20 ohm meters, actually that should say resistivity of 20 ohm meters, and its dimensions are below, what is its resistance? Okay, if rho, resistivity, remember this is a typo right here, this should say resistivity, is 20 ohm meters, okay, the length over here is 7.8 centimeters, which I convert to 0.078 meters. And then the area is this guy. And then so if the radius is 4.9 centimeters, then I'm going to have to use pi r squared to find the area. So it's pi times 0.049 meters squared, which gives me an area of 0.0075 meters squared. Okay, so resistance is rho, length divided by area, and so 20 times 0.078 divided by 0.0075 gives me a total resistance of 208 ohms. So if this were a block of silicon and I were connecting this into a circuit, and this were a part of my circuit, this block would have a resistance and would resist electricity 200 with a resistance of 208 ohms. Okay, so we use resistance most often in components called resistors, and this little squiggly line is the symbol that we use for resistors in a circuit diagram. Okay, and they look like this in real life with little stripes, and you will see them more when we do labs. Okay, so resistors are circuit components of various resistivity. Okay, they allow us to design circuits with very specific currents. If you want to reduce the current in a section of a circuit, you need to use a resistor to kind of slow it down. And so you can think of them as like different sized and shaped pipes that would change the flow of water in your house. You're going to have a different pipe going to your shower, then to your washing machine, then to your kitchen sink, because you're going to want different pressures and speeds and so forth. Okay, so if you think about it, the little stripes on the resistors actually are a color code to what their resistance is. Okay, so each color corresponds to a different number, and then usually there's 4 bands. Sometimes there's 5 band resistors, and you would use and you have like a different system for that. But basically, each color corresponds to a different number. So green is like 5 or 10 to the 5th, and yellow is 4 or 10 to the 4th. It kind of depends. So, for example, green, blue, red, gold. You look up at the first color, green, and so the first digit is 5. Okay, blue is your second one, so your second digit is going to be 6 because the second band is blue, and blue is 6. Okay, red is your third band, and so that means you are going to multiply that by 100. So you add 2 zeros. So now our resistance is 5,600. And then that last band is your tolerance, which means that it's going to be 5,600 ohms plus or minus about 5%. So that's pretty good. That's a pretty good tolerance. But it means it's going to have a little bit of wiggle room, but it's going to be close to 5,600 plus a little bit, plus or minus a little bit. Okay, so that's the end of this video. When you see me again in class, we're going to talk more about resistors and how to calculate current and voltage through resistor using Ohm's law. And then we're going to actually identify some resistors using that color-coded band. So that's the end. I will be checking for notes in class or giving you ICU. So I will see you then.